So on that note, our recording has started. So code of conduct today, we're just going to keep microphones on mute unless you have something to say. I'm a person who gets very easily distracted by sounds. So if the microphone is on and there's dogs barking, someone eating in the background, et cetera, I'm going to lose my train of thought, and this will just take longer. We're also going to be using the chat function. If you'd prefer to use the mic, you're more than welcome to use that. But the chat is also open if you'd like to chat about the activities or what we're doing. But we're going to try and keep that on topic as well. And last but not least, we are going to be learning. We're going to be trying some new things. So let's just keep this classroom respectful. Trying new things is often very intimidating. And if we are all supportive, then we can just have a better time doing so. We're working in Zoom. We've been doing this for years, so I'm not going to dwell on the controls for Zoom that much. But I am going to step into our land acknowledgement. And I'd like to ask everyone to just take a moment and picture to themselves what comes to mind when I say the word land. And I'll just give us a couple moments to do so. For myself, I see myself standing atop a hill and just looking over a vast landscape. And I'm experiencing it with all of my senses. I can see trees rustling in the wind. I can hear the cries of animals as they live their lives and do what they need to do. I can smell the different trees and I can smell everything that comes around. And I can also see a river, and it's going through this landscape, providing nutrients to everything. And really what I'd like to emphasize with what I'm seeing, and probably what you're seeing too, is how connected everything is. The trees are providing nutrients to the animals who may be consuming the trees, and then those animals could in turn provide nutrients to other animals as the circle of life continues. And then the river is providing nutrients all across the land and potentially even to people who live there. But it really is an interconnected scene, and that is what I want to highlight here. And why should we consider Indigenous perspectives to nature? The reason is this interconnectivity. Every single decision we make, every single action we take is going to have an impact on the environment we reside in, positive or negative. And the indigenous peoples of Turtle Island, also known as North America, have been here for tens of thousands of years longer than settler peoples or colonizers. And so they have an innate understanding of the land and the connections that flow throughout it. But which perspectives should we be considering? Because Ontario is home to so many different Indigenous peoples across it. What I'm going to be doing for today is I'm going to be focusing in on the peoples across or around Ontario Tech University. Ontario Tech University is situated on the Williams Treaties, which is a part of the greater Anishinaabe Nation. Other nations that are present here are the Algonquin, the Ojibwe, the Odawa, and the Potawatomi. And so these are going to be the key perspectives that I'm going to be considering throughout today. And the way I'm going to be considering these perspectives is primarily through the concept of Etowoptimunk, or two-eyed seeing. If you think about how you see the world as someone with two eyes, if you do have two eyes, if we're able to see depth as we look around. And if we cover one of those eyes, we lose that depth perception. This is exactly what we're doing with two-eyed seeing. With one eye, we're looking with the more Western perspectives that we're more familiar seeing in a science, technology, engineering, math classroom. But at the same time, we want to be looking with a more traditional perspective as well. And only by using both of those eyes, the more modern and the traditional perspectives at the same time, can we see the world in the depth that it has. And I mentioned science, technology, engineering, and math. We should be relatively familiar with what the individual components mean, but I challenge you to think about how each of these four components can all come together in what we're doing today. How is science relevant? How is technology relevant? How is engineering relevant? And how is math relevant? They're all going to be coming out today, so look for that. Our schedule for today, we're just a smidge behind, but you know what? That is a-okay by me. We're starting off with welcomes, introductions, and land acknowledgement. We are just wrapping up that now. And then we're going to move into what exactly is LEGO EV3 Mindstorms, that being the kit that we are working off today. If you have just joined us, I'm pasting a link into the chat. That link will take you to the Education LEGO page where you can download the EV3 software. This is what we'll be using today, and if you want to follow along either now or on your own time, I would highly encourage you have that software ready to go. So we are going to be talking about what exactly LEGO EV3 Mindstorms is. Then after that, we're going to dive into coding, the curriculum, and EV3, and how all three of these things come together into one beautiful canvas, I would say. We're going to also talk about the engineering design process, because this is going to be relevant as well. The engineering design process is terrific for solving open-ended problems, and that is going to be what EV3 is beautiful for doing. Then we're going to dive into how we can actually code with EV3. We're going to start off coding with the motors, then we'll dive into the sensors, and hopefully we'll have time to bring them both together into a really engaging activity. But at the end of that, we'll wrap it up. I'll take any questions that anyone has, and I have a feedback form for you to fill out. Before I step any further, are there any questions, any pressing questions that anyone has about LEGO Robotics, LEGO machinery? You are more than welcome to unmute your microphone or type it in chat. Both are a-okay. I'm not seeing anything coming up just yet, but don't let me interrupt you if you are typing. And if you do have anything to say throughout the session, I'm going to be keeping an eye on things, so don't be afraid to stop me if you have questions. I always invite questions. There's no such thing as a silly question. If you've got something to ask, probably someone else here has the same one. So the materials that we're going to need today, first off, you're going to need a computer, obviously, to follow along. The second thing is the app that I just linked. So if you are having any issues downloading the app and getting it installed, please let me know. I'm more than happy to troubleshoot with you. But as we go along, I'm going to assume that everyone has got it all set up unless I see anything in the chat that says otherwise. So what on earth is EV3 Mindstorms? What is a LEGO EV3 Mindstorm? So essentially it is a type of LEGO set. I've got the box for it right here. And what it is it's a type of robotics LEGO set. LEGO is something that we can always build in different ways. Kits will come in with instructions, which is great for helping us get started and know what the possibilities are. But realistically, we could do anything with it. For example, as I was playing around today, just getting warmed up for this workshop, I built a car. No instructions, I was just having fun. But that's the kind of things that we can do with EV3 Mindstorms. There's a ton of different parts that we can use for designs, and these are all included within the LEGO kit. And I'll just use the car to show how some of those are used. Wave so that I can get my lights back on in this room. Come on. All right, rolling with it because it's not turning on quick. So we've got gears that we can use for any kind of gears, wheels and axles. Great for getting some simple machines, some mechanical advantage in there. Really awesome stuff. We've also got axles, we've got wheels, tires, beams that I've used to build the structure. Can we not turn off all the lights in this room? Bear with me, folks. Mission accomplished. Lights are now back on. All right. So tons of useful components that are inside the kits. Wheels, beams, axles, gears, so many awesome things that we can use to design. But that doesn't even get into the coding components because it also includes an EV3 brain. And this is a type of microcontroller, and we can program this. The brain has 4 different slots to control motors, which are on this top side here by the screen. They're labeled A through D. And we can also receive information from 4 separate sensors, which are on the bottom below the buttons. And these are numbered 1 through 4. And we can program these all within this app that I have linked to you. So the types of motors that we can work with, just so we can talk a bit about those. We have one motor right here. This is a bit of a weaker motor, a bit smaller, and the axis of rotation is going to be directly inside it. So if I grab myself an axle, so an axle here, and I can put it inside the motor, and then this axle will rotate when the motor is turned on. It's also got a bit of a bigger motor. This one has a different axis of rotation, which you can now see here where this axle is through. So this one rotates along this axis, and this one rotates along this axis. This one is also a bit more powerful. So food for thought. But then we've also got 4 different types of sensors that we can look at. The first one is probably the most simple. It is a touch sensor. Basically, when we press this red part on the front in, it detects a touch. And we'll talk more about how that works later. We've also got a color sensor. So if you're familiar with Ozobots or anything like that, this is pretty similar to what's contained within those. It can detect the color. It can also detect reflected light intensity. Very, very useful. The third one is a gyro sensor. So essentially this sensor can detect how much it is tilting in specific directions. And that is all 3 axes, X, Y, and Z. And last but not least, I have an ultrasonic sensor. So this sensor would be able to detect the distance between itself and an obstacle in its path. But we will talk more about those as we get coding them, because it's better to show as opposed to tell. So how do I set up the EV3? Well, the first thing is you have to ensure that your brain has batteries. So I've got the EV3 brick or brain right here. And on the back of it is a battery pack. I'm just going to pop this off. And so inside you can put 6 AA batteries, which is very cumbersome, but probably the cheaper approach. Or if you have an EV3 brick, these are rechargeable batteries. You can place that in instead of the 6 AA batteries, but both will work just as well. Make sure I get that brick in properly. Once we have the battery in the brick, we can press this center button and it will turn red and the Mindstorm will say starting. And so I'm going to leave it there for a second as it gets set up. The next thing we're going to have to do once the Mindstorm is turned on is we're going to have to connect it to our computer. And we actually have several different approaches that we can do this. The simplest by far is just a USB connection to your computer. USB into the computer, micro USB into the EV3 robot or into the brain, and the port is right here on the top, right next to the motors. But there's a definite downside to this. The cable has a finite length, and it means that we have to be tethered to our bot at all times, which is disadvantageous because it's nice to be able to use technology and as much of it as possible. And so we're going to be going with option B, or I will be using that. Number one, it's the more complicated option, wireless connection via Bluetooth, but it also allows me to just show you how it's done. So the first thing you're going to want to do when you're connecting to Bluetooth is once you have your EV3 all ready to go, you're going to press the button on the right side, so this button right here, to bring yourself all the way to the settings indicated by a wrench at the top. And then the third option down from there will be Bluetooth. Press the center button to select it. and then just make sure that Bluetooth is on and visibility is on. And so I'm just going to go into my Zoom to make sure that I can show this. So hopefully you can see that my visibility is checked at the top and my selected Bluetooth is checked as well. So that means that this device is ready to be found. I'm going to go down, select that check mark as my final one, and now my device will be discoverable by Bluetooth. Now I can go into my computer settings, get that all set up. I have two EV3s here, which is always fun for finding out which one is going to actually be discoverable. So I'm just going to dive into Bluetooth settings and just try to connect to either one. And then when I do get that, I'm going to get a prompt on the device that asks me if I do actually want to connect to that computer. And it will ask for a passcode. And I'll just stop share and share my desktop so you can see exactly what I'm looking at here. We will get a bit of an echo here. So I'm now setting a passcode for the EV3. And now what'll happen is because I didn't do it fast enough, I'm going to have to try again. This is the annoying part about the Bluetooth connection. You have to do everything quick. So I'm going to connect to my EV3. And now it's asking for that pin. It defaults to 1, 2, 3, 4. So I'm just going to leave it as that. And because I did everything quickly this time, my EV3 is now connected. And now I can step out of, I'll just stop the share so we can see things in the EV3 classroom without my face in the way, because we don't need to see that right now. And so now here we are in the EV3 classroom. Basically, all I've done is I've started a new project, and I've called it project, which is just the default name. And here we are. The thing that should be catching our eyes is the connect icon in the top left-hand corner. That should say open a brick connection. That's what we need to do now. So this is just essentially giving us the instructions to connect via Bluetooth, turn on the EV3 brick, enable Bluetooth. So just walking through those exact steps I just talked about. So you don't have to worry about remembering everything. It's all here in the app. And then once you've got it all connected, you can pair the device. And so I'm just clicking the connect button, and it's going to bring these back up. It's very frustrating sometimes having to multi-connect. But if things work out properly and you connected via Bluetooth before attempting to go through that, the process is much nicer. And now we should see a green dot up here above our brick showing that we are connected. So now let's try running something because we got a code. But before we do that, I am going to step out of this and just talk a bit about what exactly coding is and how it's connected to the curriculum so that we are on the same page and that we know that what we're talking about is actually relevant to our students. I apologize for jumping back and forth between my shares. There we go. There's the right one. All right, so we have now connected everything to the classroom software, and so it is now time to code. But what exactly is coding? Coding is essentially just a set of instructions. We give them to electrical devices like computers, phones, traffic lights, EV3 bricks, etc., etc. And there's a ton of different languages that we can code in, and this is actually true with the EV3 brick as well. I'm focusing on a coding language that is very similar to Scratch, which is going to be terrific for transferable skills for your students, but that is not the only one. They have Make Code. They have Python. They've got many, many other coding languages that you can work with EV3. So if you do want to explore a different coding language or you use a different one already in the classroom, you can do that. That is no worries. But the one we're going to be focusing on today is going to be very similar to the one that's used by Scratch. So if you've used that in the classroom or your students are familiar with it, hopefully that'll be a bit less intimidating for them when they first take a look at EV3s. But essentially, the gist of coding is inputs and outputs. We provide something to the program, and that program is going to process that input, and then it'll give us an output. So for example, let's take this car that I've got here, and you can see that I've got a proximity sensor here. So I could say for my car, I want my input to be when I press the button on the EV3 brick, and then my car will go. Mind you, the brick would be attached to the car. It's currently not right now because I've got it separate to show you things. But my input could be pressing the button and then my car goes. But we don't just have to have one input or one output. We can have multiple of each. For example, I mentioned that we've got this distance sensor on the front of my car. I could have a second input that is the distance sensor. And when the distance sensor detects something that's less than, I don't know, 10 centimeters, the car stops. So that's a second input and output. When my input is a distance reading that is less than a certain number, my output is going to be stopping the motors. So we can have multiple inputs and multiple outputs. And that's useful because if you want to think about it, the sensors that we can attach to the brick, those are inputs. And the motors that we can attach, those are forms of outputs. So that already gives us some ideas for the kinds of things that we can do with inputs and outputs. But there's also the coding expectations. I do want to quickly talk about the structure of them. Each grade is going to involve solving problems and creating computational representations. To me, this is creating new code. And then each grade will also have reading and altering existing code or editing code. So we want to be making sure our students are writing new code and editing existing code at any point. But then we want to be looking at the principles that we're introducing at each grade. Grade 1 is sequential events. So events happening one after another. So I go here, and then after that, I go there, and then after that, so on and so forth. A direct sequence of events. Grade 2, we're looking at concurrent events, or when we can have multiple things happening at the same time. So say I'm driving along, but I'm also checking my my proximity sensor at the same time. That's concurrent events. Driving along, but also checking my proximity sensor. Repeated events. Maybe I'm not just checking my proximity sensor once. Maybe I'm checking it every 3 seconds. How am I going to set that up? Using loops, obviously. Having experience with coding, but repeated events, that's really what it is. Using loops to do things many times in a row. Nested events gets a bit complicated. It's essentially loops within loops. So say every time you check the proximity sensor, maybe you want to only check that every fourth corner of a turn. It's a bit more complex situations that allow us to do nested events, but essentially it's when we have a loop within a loop. Grade 5, conditional statements. That's just when we're making decisions with our code. If something happens, then we make something else happen. So if we read a distance less than 10 centimeters, then we stop. That's a conditional statement. And so that would be a grade 5 expectation. Grade 6, efficient code. The gist of efficient code is just trying to do the same things with less lines of code or less blocks. So just trying to find creative approaches to the same situations. So for example, instead of saying go forward, go left, go forward, go left, go forward, go left, go forward, go left, I could say go forward and then left 4 times in a row. Many less commands, but same thing happened. Grade 7, define counter subprograms. So that would be any loop where we are keeping track of things that are happening. So maybe we're looping only from 10 to 20. That would be a defined count. Or we can also have subprograms. So when we break a larger program down into smaller subcomponents and have those coming up, I'll show more about that. But I would argue that that grade 7 expectation is really good for breaking down any kind of coding activity. And then last but not least, grade 8, analysis of data. So that's going to be taking measurements and being ready to do an analysis with it. So maybe we could use the proximity sensor and mount it on a car pointing upwards to understand how level is the roof, how level is the floor compared to the roof. And so we could get measurements for the distance between the floor and the roof, minus an offset, of course. But that would be an example of something that we could do with offset of data. But these are really the big math coding expectations. And so we're going to dive into actually programming EV3 now. And I'm just going to stop share, pop into my EV3 app once again and share that. All right, so EV3 Classroom. So now we're going to actually dive into some coding, and I'm going to talk about what we're coding as we produce it. So generally, the first kind of thing that someone is going to want to do when they get a new device is we're just going to want to create the simplest program we possibly can. So I'm not even going to worry about motors. That's too complicated for now. Movement, too complicated. I'm just going to go to display. And so I'm going to display something very, very simple. I'm just going to write some text at line 1. I'm going to change it from EV3 and I'm going to change it to Hello World. Because, whoops, spell it right. Because number 1, it's just more cheery. I like saying hello world. But also number 2, that is something that a lot of different programmers will do. They will just print out hello world as their first way of introducing themselves to a new coding language. So this is what I did the first time I've learned any new programming language. And so let's do that today with learning how to work with EV3. So I've got the simplest program. When the program starts, we're just going to write hello world at line 1. Now, how do we run this? It's actually really simple. All we have to do is click the play button in the bottom right-hand corner of our screen, and you will hear my brick chirp a bit. And now it's running the code. And as I show it to you a bit closer, I don't know if you can see that, but it is essentially saying hello world on that first line. And so there we go. We've started doing something. We're using the brick and we're typing things on the display, which is awesome. And we can do more things with the display as well. We can display some emotions. So I'm going to take a look at that display eyes neutral, and we can see that there's a ton of expressions, eyes, information, Lego information. And so what we can do is essentially have this display be a really great way of interacting with the user of our program, providing outputs to let us know what our inputs might need to be. For example, let's say we have a program and we're doing something and something that we don't want to have happens. So something that is not good. Maybe we could look at the disappointed eyes for 2 seconds. Maybe that's what's going to happen. And so to try my new code, all I have to do is press the stop button and then the play button one more time. It will chirp again. And now you should be able to see my disappointed eyes. Oh, my brick died. Fortunately, I have 2. Or I have a second battery pack. That's what happens when you play with EV3s all day. So I am going to have to reconnect my EV3, so this is a good chance to just demonstrate that. Obviously suboptimal, as it does take a little bit of time to do, but hey, that's no big deal. We can also have a bit of fun and actually create some editable things in these segments. So I'm going to get rid of those eyes disappointed. I'm going to put back the write EV3 at line 1. And we can actually do some math in here as well. So for example, let's say I want to say something. Let's say I want I want to have 10 apples. It's going to sound really weird right now, but bear with me. Bear with me. And so I'm going to create a second right. I'm going to put it line 2 though, because we don't want to have it overwrite what we put before. We want to have it on the line below. Now, what I want to do here is I know in the operators, this is where we're going to find a lot of our math options, just like from scratch. I want to have a random number of apples. So I'm going to say, we're going to need this random here. So that's obviously what we need. And since we're going to be joining some strings together, we can use this join function here. And this will be how we do it. So I can say, I'm going to put a space. I'm going to choose a random number between 1 and 15, or actually no, 1 and 10, because I'm going to want to have the maximum number of apples. And I can grab another join, put a space, apples at the end, move this here. So this is going to join my random number and space apples. And then I'm going to join that with this. So I have a random number of apples. And so watch what happens when I put that inside my right line. Make sure that my EV3 is all set up. And of course, the Bluetooth turned off when it powered off, but that is a-okay. Get my Bluetooth going, EV3. Wrong one. There we go. All right, my EV3 is now connected. Now I'm just going through the connection process one more time. Connect. Then I just select the EV3 that I've got connected. And it should close in just a second, assuming everything works right, although sometimes it does like to be grumpy. Come on. Why do you do this to me, Brick? Are there any questions while I get my brick connected again? Make sure that I've got the chat open as well. Try the other brick, because this one's being annoying right now. And I don't have my USB connector right now. Anyway, what this essentially would do would say that I have a random number between 1 to 10 apples. And so we can actually have some variability in the lines that we've got here. But what can we do with this? Well, I alluded to it a little bit with variables. We can use variables to essentially give us a bucket to put things in, and now we can actually work with this same number. Because if we were to pull another random 1 to 10, this first one would produce a different number than the second one. But if I create a variable and I call it number of apples, now we can have some fun. I can set number of apples to that random 1 to 10 and place this here. Second one is open. Good, good, good. Get myself connected. Bluetooth EV3. Yes, yes. Okay. EV3. Connect, connect, connect. I love fighting with technology in the middle of a workshop. Especially when it works perfectly the first time around, and now it's just being annoying. All right, give me 10 seconds. I'm going to get my USB cable. Be right back. All right. Minor sprint across the building to get my adapter. No big deal though. Plug in the USB end. Connect to the other end here. And now you can see that that was very easily connected, but the downside is, of course, I'm tethered to my PC. So now I'm going to run this program. And so now what it's telling me is I want to have 10 apples on line 1. But line 2 is now saying I have, and it randomly chose 6 apples. So obviously that's not enough apples, but we can say that even within the program. And all we need is 2 more lines to display that. So on line 3 and line 4. So the question is this enough apples? And the answer is going to come from operators. And so we can grab one of these hexagons that will give us a response of either true or false. Place it in. And so what we want to know is the number of apples greater than 10, or is the number of apples equal to 10? So I'll get rid of that and place the equal in here. And so I can say equal to 10, place the number of apples on the other side. And so this will report either true or false. And so I can stop, run my program one more time. And what it says to me now is, I want to have 10 apples. I have 3 apples. Is this enough apples? False, because 3 is not equal to 10. So there we go. That's how we can start to use the display to show some things. We can even do math within it. We can make decisions, and we can show the logic of our decisions. So that's really the huge advantage of having the display. If you've used Microbit, Microbit just has that 5x5 LED grid. This has so much more capabilities within it, which is just great. But we don't really care that much about just using the display. What we want to do is we're here about the robotics and the machinery. So how can we use the motors? That's really what's interesting to us. And you don't have to worry about me getting rid of anything that I'm showing you. I've got it already up here on a different project. So it's all saved. I will share it all with you afterwards. Don't worry about me deleting things as I go. So motors, how do we use them? Well, we've got this whole category here for motors, and they're pretty straightforward when we look into it. We can set the speeds. We can set it to run for a number of rotations or just start it at a certain speed or power. We can track the degrees that we're counting or how much it's rotating, remembering that 360 degrees is a full rotation. But let's try it out. I'm going to grab this start motor block here. Although I want to have a bit of control over how long it runs for, So I'm going to step into this control section as well. And I'm going to only run the motor for, let's say 3 seconds, just to make sure we can see it. And then in motors, I'm just going to stop the motor afterwards. So you can see I'm working out of motor slot A for both of them, which is good, which means I'm going to be using the same motor each time. Now, all we need to do to connect them is grab these little connectors that will come within the kit. There's 3 different lengths, so make sure you choose the appropriate one for the situation. And you just plug it into the right slot. So I've selected A from my motors, and so I plug into slot A here. And then all I have to do is plug it the other end into the motor, and preferably get myself a little something so that I can see the direction the motor is pointing in, just to make it a bit easier for us to see the turning. And now, just like before, all I have to do is click that play button. And so you could see this little bionicle eye here, that's what that piece is actually called, rotated. And so it really is that easy to start using the motor. It's one of the simpler things. And so you might be wondering, what is the point of that? What could we really be doing with the motors? Well, you saw me over there working with a car. And so I've actually got 2 of this kind of motor, one running each of the back wheels. So this is a rear wheel drive car, dual motored, like some of the new Teslas actually. So we can do some awesome things and show what a dual motor car is. It's really just a car with 2 motors running the wheels. Or we can do some simple machinery with it. For example, here, I've got a connection of gears all together. And what happens when I run this? And we can actually see some really fun stuff happening with these gears. We could see the mechanical advantage in action, and we could see the gear rotations in action. We can note that every gear will be alternating direction. So if this one is rotating this way, this one will rotate the opposite. This tiny one, the opposite. This dark gray one, the opposite. And finally, this last big one, the opposite. And I put a few more bionicle eyes so we can see that. But it was a bit hard to see it when it was going so fast. So I am going to slow the motor speed down. I'm going to set it to about 30%. Really slow it down. And now stop and play one more time. Yeah, now we can see that. Make that run for a bit longer so we can really talk about it. But we can see how these 2 gears are moving at the same rate, but in opposite directions. And this tiny one here is absolutely flying around, rotating so quickly. And so we can use this to really not only demonstrate, but to allow our students to take advantage of mechanical advantage and show their knowledge of using gears to create a system. The whole Lego platform is really great for putting these gears together. All of these components are just in one EV3 Mindstorm kit, and there's so much more that we can do about it. It's really awesome. But the motors are pretty straightforward. It's pretty much just go. You go in a direction, whoops, accidentally pressed play again. You just go in a direction, things happen. The motors are really straightforward, but the interesting part comes with the sensors. And so we'll talk about how we can program those. And so basically, here we are in the sensors. And you'll notice on the left-hand side of each block, we actually have an icon which represents which sensor we're going to be using. So this first one here with the big circle and then the smaller circle, that is going to represent the color sensor. And we can kind of gather that from some of these blocks. Wait until color is color red, ambient light intensity, etc., etc. This next one, which looks like a plus inside of a bigger plus, that is just the touch sensor. So wait until pressed is pressed. Not really much that we can do with that one because it is a simple sensor. Next up, we've got the infrared proximity sensor. And so we can wait for distance to be less than 50, range. Just get that distance as a number, remembering that these hexagon blocks will report either true or false. These oval blocks will report a number. So we can put either of these hexagon or number blocks into a space in another block. So useful. And then we've also got more proximity stuff down there. These are just the same sensor. And then last but not least, the dot with the two arrows pointing in each direction, that is just going to be our gyro sensor. So what I would recommend for you is really just experiment with the sensors, see how we can get these readings. And we can even experiment a bit with getting these readings to display on the screen as well. So I'll just show you a quick way that we can go about that. So in control, I'm just going to grab a forever repeat. And I'm going to grab myself a measurement. I'm going to rename my apples variable from before to just be a measurement. So now I've got that. So forever, we're going to be looping constantly, always going through this loop. So this would be repeated events. So I'm going to first set my measurement to be whatever I want to measure. And we'll get to that later. And then I want to display what that measurement would actually be. And so I'm just going to put that in there. And so now we can go to sensors and we can decide which sensor we want to use first. Since the first one on the list is the color sensor, let's roll with that. Let's see what the output of the color sensor will be. Remembering that the input is going to be color and the output, we don't know what that's going to be yet. So let's grab this oval for color sensor and place it in the measurement slot. So now our measurement is going to be what the color is. Now, this sensor is set to be attached to slot 3, although we can change that. I'm not going to change it though. And so I just want to make sure that I plug it into the right spot. Sensors on the bottom and then slot 3. So now color sensor, just like before, plug it in, easy peasy lemon squeezy, and then we just press play to see what we're going to get. And my color sensor is now reporting 0. Let's take a look at some different colored blocks. And I've got a bunch in my hand. Hopefully you can see them. I've got red, yellow, green, blue, and black. And so I can get some different readings. So let's grab some yellows, stick them together, and see what kind of measurement I get. It is now reporting 4 with the yellows. So it seems to be associating each color with a number. Let's see what red is going to be. Red is 5. So this seems to track. Blue, 2. It's easy to remember, it rhymes. And green, let's try that one. Green is 1. And then black, let's see what that was. I'm also getting 1 for black, so maybe it wasn't reading the green properly. Aha, there we go. If I have it at the right distance, it changes to a 3, so green is 3. But you can see that there is a different color that is associated with each one, and you can actually see that on the screen. So right above the play button on where my program starts, you can see the sensor icon. And watch what happens below it when I hold it up to the red bricks. It shows the number 5, but it also shows a red dot. So that allows us to confirm that that's what the reading we're getting is. And so we can get, number 1, that live update, but we can also display it on our screen. Let's try another sensor. I'm enjoying this. Let's get rid of this color, just toss it off to the side. Let's try the is it press, just to see what the true or false ones will look like. So I'm just going to grab the button presser and attach it. And then stop and start. And now where we saw the color sensor before, now we can see the button presser icon with a 0. And on my screen, it is saying false. So it is saying that 0 is equal to false. And if I press it, it is still saying false. Oh, now it's reporting 1. Oh, I was misunderstanding how this worked. So it is not, it can function as both some of the clever ones among you might have spotted that I accidentally left this as 1. So what was reporting on my screen was not right. But the way this can function is twofold. So essentially, on the top of our screen, on the actual app, it will count the number of presses we've made. So I'm going to press it. Okay, now it's just working as true or false, which is making more sense. That's what I had it set to be tracking. So essentially, when it is not pressed, it is saying 0. And when it is pressed, it is saying 1 or true. When I had it reading from the wrong port, then weird things started to happen. So if things are looking wonky, make sure that you're reading from the right port. Stopping once again and going to that distance sensor. So let's grab that distance in centimeters and our little friend with binoculars. At least it looks like that to me. And so download and run. And so now we are going to be reading. And you can see when I point it to a very far away corner of the room, it reads 255 centimeters. That's just the maximum possible it can read. If it's something over that, it'll just default to 255. But anything below that, for example, if I hold it to my computer screen, it's surprisingly accurate. Like it's even capturing the little wobbles in my hand as I try to hold it steady. But here I am holding my holding this about 22.5 centimeters from my screen. So this is pretty accurate. And you can see that it updates really frequently. But that's really the 4. Oh, I forgot one. Of course, I forgot a sensor. Only talking about 3, but then saying that was all 4 of them. Last one is just the gyro sensor. So that one is right here. And so downloading and running. So it's all about just tracking the angle which I'm holding it at. Although this one is just constantly increasing. So I think this sensor might be broken. If in doubt, put the sensor on a flat surface. And if it continues to increase, then the sensor is broken. And so you can see that I'm holding the sensor on a flat surface. I'm not moving it at all, but that reading is continually increasing. That is an indication that something wonky is happening, but it's not the sensor. Once again, it's just me not checking which port I'm working off of. Silly me. So I'll stop and play. And we are reading off of port 3 now, but it is still increasing. So yes, I do think there is something wrong with this sensor. That is okay though. It's good to know how to spot things that are wrong. If it shouldn't be doing something and it is doing something, that's where you figure that out. So we won't be using the gyro sensor anymore because it's not working. But now the question you might be having is, how can we do something exciting with this? Because we've talked about a lot of sensors and the motors, and so we want to create an engineering design activity because, like I said, engineering design is all about open-ended problem solving. And so I will stop my share on the wrong one and start my share on the right one. Quickly talk about that. So these are some super simple commands for EV3 and all the things that we talked about, programming them, et cetera, motors, sensors, and I'll share this slideshow with you. These are some great ways that we can start to experiment with how these work. But let's talk about a real activity because we've only got a few minutes left and I do want to leave you with something tangible. So combining the sensors and the motors is how we're going to actually start to create a real scenario. Let's say we're working at the Lego factory and we're looking to create a set. Maybe we're sorting the Mindstorm sets. I don't know. That's what we can think more about. But we're in the Lego factory and we're building a conveyor belt to automatically sort parts for packaging. We're able to sort parts by size A-OK using a sieve method, but there are several pieces with the same size but different colors, like the ones I've got in my hand. They're all 1x3 beams, so they all look like this, but they're different colors. So can we design a system and sort the colors as they come down a conveyor belt? And this is where we can start to use the engineering design process. Identify the problem, brainstorm ideas, design a solution, make a model, test and evaluate. And so I'm not even going to worry about going through the steps right now because we do only have a little bit of time. I do want to show you kind of what I got set up. And I would encourage you to think about how you could go about it the same in your own way. Take a look through these different steps of the process and think about what you could do. So what I came up with is a device that kind of looks like this. And essentially what I've got is I've got my conveyor belt being run off one of the big motors right here, and it goes along, and then looking at the conveyor belt is one of those color sensors. And so it's just looking at that conveyor belt. And now I'm just going to stop share once again, flipping back and forth. I know, go to this EV3 classroom, and I will show you the conveyor belt program that I got set up. So this is, again, engineering design process. It's something that we're not going to get right the first time. Engineers never, ever get the right solution the first time. And so this first time is really going to be about how can we start to solve this problem? And so what I've got here is a program that is going to, when the program starts, going to turn on my motor and start rolling the conveyor belt. And then I've got a whole bunch of sequential events using my color sensor. When the color detected is the various colors of blocks that we could have, red, yellow, blue, green, then it will give us different statements. And so essentially that was me kind of whirlwind whipping through the different steps of the engineering design process. But now perhaps the most fun one is testing and evaluating, knowing if what you did actually solves the problem. And so that's what I'm going to do. And really the reason I'm doing this is to show you how this is all going to come together and how we can use the sensors and the motors to create something exciting. So I've got my motor connected. I've got my sensor connected. Wonderful, wonderful. And now tilt this so you can see what I'm doing. And now I'm going to press the play button. And so you can see my conveyor belt is now going nice and slow. Now I'm going to place a blue block on the belt. And what it should have done is when it detected the blue block, it would have said blue detected. Let's place that yellow there. That time it worked. And so as we're testing and evaluating, we can think about, why did it not detect the blue block that time around? How can I make it detect that better? Let's try putting that blue block down again, except maybe a bit closer to the sensor. Still nothing. Interesting, interesting. So you can see that testing and evaluating is important. And this is really just seeing if there's a way that we can detect the colors. So putting a red one down, and it is still not detecting that. But when I hold it up nice and close, you can hear it yelling the red. So maybe it's something that I have to do, maybe repositioning my sensor. Maybe that'll help me detect these better. And I'm just holding these right up to it to see if I can make this work better. But really, that's the gist of it. Creating something that uses both the sensors and the motors, because that's really where we're going to get the most engaging designs. Combining everything together, that's going to be the fun bits. Although really, what this is going to be about is you exploring and figuring out what you could possibly do with your students, because really, with Mindstorms, the sky's the limit. There's so much creativity possible. They've obviously got the base sets that you can download instructions for, and you can build those and create some awesome stuff and work on the coding components. But if you're ready for it, you can also start designing your own Mindstorms creations, which is just another whole direction that we can go. I do recognize that we are at 5:03 right now, so I will wrap up, trying to be respectful of your time as it is a Friday afternoon. So yeah, the last piece that I'm really going to have for you is on the slide right here. So thanks folks for coming out and learning a bit about Lego Mindstorms and how we can start to program them, the awesome things that we can do. Of course, I'm a huge believer in feedback and constant improvement. So if you have any feedback for what I've done today, ways that I can improve, anything like that, I'd really appreciate it if you could fill out my feedback form. You can scan the QR code that is on the screen, or I will paste it in the chat for you, so you can fill that out. But thank you again for coming out. I really appreciate it. It says a lot to your quality as teachers that you're here looking to improve. What age would I recommend for this? So I would definitely recommend working with this with older, more mature students. And the reason for that is the number of parts and the kits. So this kit that I've got right here is all nicely organized. There's a few parts missing, but that's because I'm using them. It's so easy for this kit to just not be organized. And if you do work with this with younger children, I could very easily see that exploding. That being said, if you are willing to do a bit of the organization beforehand and essentially lay out the components that you'd want to work with them, you could absolutely make this work with younger students. There's a lot of really awesome stuff. For example, working with the gears and really showing simple machines in action, that would be really beneficial for some of the younger students, like grade 3-ish. But the maturity level that you would need to really have success with the entire kit altogether, I would say would be much, much more directed towards grade 7 or 8. Does that answer your question? Glad to hear it. So the Lego We Do kits, they are more built towards building with the bricks. So essentially what we've got here, like all of these beams and axles and whatnot, these are called Lego Technic. So it's a bit more oriented towards like robotics and science stuff. The We Do kits have a bit of the Technic components, but they have more just brick components. Those ones I would say would probably be a bit more beneficial for the younger students. Really great as a way to introduce the students to what they can do with Lego and kind of the creative potential of it, while having a much smaller and easier to use kit. So I would definitely recommend using those We Do kits with younger students. Probably the junior ages, grade 4 to 6, I would say would be the optimal range for the We Do's. Are there any other questions as we are in here? If not, you're more than welcome to hop out. Thanks again for coming. Like I said before, the fact that you're out here on a Friday afternoon learning about ways to create engaging activities and lessons for your students really speaks a lot to your quality as a teacher. So enjoy your weekend. You've earned it. That being said, if you do have more questions, I'm not trying to shoo you out. You're more than welcome to stay in here and ask them. I'm going to be here.
I'm just trying to get the link to come up, the feedback form. You posted it already, right?
Oh, shoot. No,
Okay.
that's my bad. I'm so sorry. I thought I
No,
pasted it
I
into
asked
the
the
chat.
question right as you were gonna do it, so I interrupted your thought process.
I did the Control C half. I just forgot the Control V half.
There we go.
In terms of charging the battery packs, because I got a DM question about that. So essentially, I have a charging cable right here that I use for that. So it came with the EV3 kits. Just looking at it right now. Yeah, it's just an official Lego product, but basically it comes in and it's just got the DC adapter. You plug it into the kit, plug it into the wall adapter, and then you get two lights. Green one indicates that it's charging, red one indicates that the battery is low. But it is just a one wall outlet to one battery pack situation. They do take a hefty amount of time to charge, though. They take probably about twice as long to charge than they do to deplete. So if you're using the batteries for about an hour, you should expect to charge them for 2.
Are the Mindstorm apps on the Chromebooks already? Like, or do the students have to download them? Or do you recommend using the iPads instead, like for the software?
If it's not on the Chromebooks already, lights, stop this.
My office does that all the time too. Because a
If
timer.
it's not on the Chromebooks, then you might be able to convince the board to allow you to download them because it is an official Lego education product. Like it's the app that's supposed to go with the Mindstorm kits. So if you have the kits but you don't have the app on the Chromebooks, that I would say is a problem and should be rectified.
Yeah, I haven't checked for the Mindstorm. I did check for the WeDo. I couldn't get it on my Chromebook, but I got it on the iPad. But I haven't checked for the Mindstorm yet. I know we only have a couple Mindstorm kits at our school.
Mhm.
We have a bunch of the WeDo, so I probably will do the WeDo instead. But I was just
Absolutely.
curious.
Yeah, so I would absolutely say to check in on this. And it's entirely possible that the Mindstorm software won't be on because this is actually a very recent update. They've very recently released the Scratch for Lego Mindstorms. As of like prior to Christmas break, that wasn't there. So this is brand new stuff that we're talking about. So if the board hasn't looked at the devices that they've got, then it's entirely possible that they won't have this new software on. And like I said, this takes advantage of the transferable skills with Scratch that students are learning, making them more comfortable with the software.
Mhm.
So yeah, I would say that the Chromebook should have this installed, but they likely won't because it's a new release. So that might actually be something I bring up to the boards. I know I work personally with the Catholic board a bit more, but are you with the public board?
Yeah, DDSB. Sorry, I didn't realize you had more than just the DDSB. So you work
No,
with.
no worries, no worries. I work with a ton of boards. I'm just working really closely with the Catholic board right now. I actually have a placement program where I'm going into Miss Mendez's school, the other participant in this call, which is really awesome.
Nice.
But yeah, so I'll reach out to the STEM leads at the board and just ask if they're aware of the new software for Mindstorms and just see if that's something that we can get on the approved software list, because it's just so much nicer to be able to use the technology with the right software and everything.
Yeah, it's difficult to do the coding activities if they don't have the actual software to work with. Otherwise, I mean, they can do the actual building, but it's missing a whole lot.
Absolutely, absolutely. And I think it would be better to try and do the the coding on the Chromebooks just because they're a more accessible piece of tech to have in the schools versus the iPads. And
Yeah,
also you're going to have more coding platforms on the Chromebooks in the future. So just building comfort on coding with computers would be beneficial. But that being said, iPads, great alternative. Why not use both?
Yeah. All right. Sorry.
No worries.
Thank you so much for your time. Have a good day.
My pleasure. Have a great evening and have a great weekend. Woo. It's always fun overestimating how long these activities take. I enjoyed though. Teachers are great.